there's like certain effects on craps is because once you have 2 die, the randomness kind of starts dissipating because it's, you know, 7.
It's okay.
Should.
How about 11? How about 6? Oh, this is such good. Let's come back to this.
That's rolling close to the same number twice.
Say that again?
Because if you're getting a low end or a high end number, you're rolling close to the same number
Oh,
twice.
hold that thought. Hold that thought. Okay. So what I'd like to do now is I want to continue this discussion of probability distributions. I want to continue the discusn of the idea of listing out the possibilities of an experiment. So the experiment, you can see why rolling 2 dice would be the kind of thing you want to pay attention to. Dice are the cornerstone of many gambling games. It's not the cornerstone of life, but it's the cornerstone of much in Vegas. I like going from concrete to more ethereal, which is where the life insurance comes in next time. So you're rolling 2 dice. Let's try to set up the distribution of what can happen if you roll 2 dice. Because if you know what can happen if you roll 2 dice, you can have an educated idea of how to bet if you should bet at all. Let's come back to that, okay? Yeah. So let's start with the random variable x, which is the sum of the pips now. The sum of the pips. Okay, what are the possibilities?
1 through 12.
Careful.
2 through 12.
2 through 12, right? You can't get 1 anymore because you're rolling. You get 2 through 12. So snake eyes through boxcars. So you've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And a little note here. There we go. We'll take care of that later. Fair enough? Okay. Now, rather than collecting all that data, I don't want to ruin my streak of adding correctly in that lesson. Let's just see if you guys can figure out what these probabilities have to be. What should I put in for probabilities? What do you think? There's 11 outcomes. 2, 3, 4, 5, 6, 7. Good. What percentage? What should I throw in?
Which number are we talking about?
No, any of them. What do you think? It depends?
Yeah.
Oh, I like the it depends. Jay!
8.34%.
8.3. Where the hell did that come from?
Divided by 100. Oh, I'm sorry. 11.
Oh, I see what I see what he's doing. I see what he's doing. He took, there are 11 possible sums. 2 through 12 is 11 possible sums. He took 100%. Now, Jay knows that the sum of these probabilities has to be 100%, right? So he took that 100% and divided it by 11, because there are 11 possibilities, which gives about 9% each. So there's a 9% chance of snake eyes, a 9% chance of 12s, a 9%. Let me just do a quick show of hands. How many of you rolled snake eyes just then? So in other words, you went 1 and 1. You threw the dice and got 1 and 1. Raise hands and show me how many. Show me how many times. 1, 2, 3, 4, 5. 5 snake eyes. You guys would have lost your ante and craps, right? Good. How about boxcars, which would have been double 6s, 6 and 6 at the same time. How many did you get, Blake? 1, 2, 3, 4, 5. Almost the exact same people, too. That's kind of fun. How about 7s? How many of you rolled 7s, and how many times did you roll 7s? Now that's interesting. That is a lot more than 5, isn't it?
Sure.
How about 4s? How many 4s did we get? Ooh.
2 4s or 8 4s?
A sum of 4.
Okay.
A sum of 4. Now look at that. Look at those hands. What I'm seeing, not many of you got snake eyes. Not many of you got boxcars. A whole buttload of, it's a mathematical term, a whole buttload of you got 7. And then 4 was somewhere between snake eyes and 7.
Bell curve.
This does not, well, let's do it this way. Rather than getting too specific, it doesn't sound uniform, does it anymore?
No.
Now, could we have just gotten totally weird data and it is uniform? Isn't it possible? Good. It could happen, but it's not.
Probably.
It's possible, but sorry about that. That was a terrible noise. It's possible, but not probable. Candace, back to your 244. If these were actually uniformly distributed, we shouldn't have seen what we just saw. So now my question is, what is what we just saw? What distribution is actually underlying this? Okay, makes sense. Dave, go ahead, help me out.
The fact that it's 2 die, if we had a 12-sided die, it would have been uniform.
We don't.
1 through 12.
Oh, good for you. Good, or 11-sided die.
Yeah.
If we had one 11-sided die with, I can't picture what that would look like, but if it had a 2, a 3, a 4, up to a 12, and through that, Jay, that would be your 9%, 9.1%, 9.1%, all the way down, correct? Fair enough? 9.09, something like that. Good, but we don't. We have 2 dice combined together. How does that change things? Please.
Lisa.
Lisa,
Yeah,
thank you. Damn it.
because there's more ways to get a 7 than there is a 2.
Well, how many more?
And I don't know.
Good for you, sister. How many more, John?
So would you times 11 by 2 and then divide that by 100?
Say 11 by 2. Why 11 by 2? That's 22.
Because there's 2 dice.
Oh, there's 2 dice. Ah, this
4 ways.
this has something to do with it.
6 and 5 are probably 6.
A 6 and a 5. Okay, let's start. You know what? Let's do this. Let's do this first. Let's create a column of just how many ways can we get each of the sums for starters. So grab your dice. Let's just go through it. Let's take our time and go through it. Grab your dice. Make me snake eyes. Make me 2. Make me a sum of 2. Not rolling, just actually turn it in your hands. It might take a while to actually roll snake eyes. Make 2 in front of you. Okay, did you do it? Now make it a different way.
Can't.
Good, you can't. There's only one way to get snake eyes. Okay, take care of yourself. There's only one way of making snake eyes. That's a good start. Fair? Okay. Say that again?
Same with 12.
Kevin says same with 12. Do you believe him?
Yeah.
I do. Because double 6s is the same as double 1s. It's just twice or 6 times as valuable on the dots. Good. I'm with you so far. With you so far. Thank you, sir. Okay. Make a sum of 3. Make a sum of 3 on the dice. Do it! Or I'll sing some more.
I'm just wondering how
Okay.
you're counting combinations
only
because
one.
We're doing it right now, right now, right now, right now. Do it. This is why you have 2 different colored dice in front of you. FYI. Make a sum of 3. A sum of 3.
Oh, sorry.
That's okay. That's okay. Do it again. Do it differently.
Oh, changing the dice.
You can, can't you? You can. Because if you, like Teresa's got a blue and a green die. If she has blue 1, green 2, that's different than blue 2, green 1. She actually has to turn the dice to different faces.
Right.
That's not like snake eyes, right? Snake eyes, you have a 1 and a 1. You can't turn them. It's the same ones. There's 2 ways to make a sum of 3, aren't there?
Same with 11.
Same with 11. 5 and 6, 6 and 5. Very nice. Nice connections, my friends. I
So
appreciate
can we
this.
just fill it in now?
Let's keep going. You guys want to keep going?
Yeah.
No, we're going to keep doing it together.
If we fill it in, will it just meet in the middle though? If we just kept
Let's,
going 1, 2?
shit, let's find out. Make 4. Go. Say it again, Teresa. Say it again. 4 ways. Make them for me. Make 4. Make 4 right now. Make 4. So a sum of 4. Okay, Johnny's got 2 and 2. Rachel's got 1 and 3. Make 4 again. I'm keeping track. We did 1. Can you make 4 again?
Yeah.
So now up to 2. Make 4 again. Did you get a third way?
Yeah.
Make 4 again. You can't. Why can't you? Count the ways to make a sum of 4. 1 and 3, which can be switched to 3 and 1 because of different colors of dice. The damn 2 and 2, you can't switch. It's like snake eyes, but it's like double snake eyes. So there's only 3 ways to make a 4.
Same with 10.
I love it. Kevin's a very, very important component of this class. Same as 10. Very good. Thank you, sir. Does everybody see what Kevin is saying and why it's valid? I love it, by the way. Thank you, sir. All right, make a 5. Make a 5. Yeah, you do.
4.
We have a vote for 4. Are there 4 ways to make a 5? 1 and 4, 4 and 1. 3 and 2, and there's no doubles to concern ourselves with because there's no 2.5. So there's only 4 ways.
4.
Kevin?
Same with 10.
Same as 9. Same as 9, right? 4 and 5, 5 and 4, 3 and 6, 6 and 3. Seeing the pattern, Rachel, you got the pattern now, right, sister? How about 6s?
Oh, wait, 5.
5 and 1, 1 and 5, 4 and 2, 2 and 4, double 3s, which can't be moved.
Yeah. 5.
Same as 8.
You know.
Yeah. Same as 8.
And finally, we have 1 left in the middle, which has to be the 6. Now, if you don't believe it has to be the 6, figure it out. 1 and 6, 6 and 1, 2 and 5, 5 and 2, 4 and 3, 3 and 4. And no doubles. What do they add up to? Whole class is deflating.
So you got threes.
That's 10. 10. 36? Am I adding correctly? 36!
Yeah.
Is there any coincidence that there were 6 outcomes for one die and there are 36 outcomes for the second? No coincidence whatsoever. After you finish your project for Thursday, you'll realize you could have known there were 36 outcomes because each die has 6 outcomes, 6 squared. Somebody, Johnny, you said 11 times 2. It's 6 to the second power. That's where the 2 comes in. If you had 3 dice, it'd be 6 cubed. And so Yahtzee is 6 to the 5th. There's a pattern in there, but that was more of a hidden one. I like the way we did it instead. I like this way better. Okay? Thank you for pushing for this. Now that we have that, we can create this column, can't we?
Yeah.
Because now all we gotta do is take each of these and divide it by 36. So you got 1 36th here, you got 2 36th here, and so forth and so on. Caitlin, was that your hand up with a question back there? Am I just envisioning things? No, I was envisioning things. Okay, let's finish this off. Notice that rolling a 7 is just as likely as rolling a single die and getting any number. So that's why it seems, this is why craps is genius. You think to yourself, holy crap, no pun intended. You're gonna let me win. You're gonna let me win at craps if I roll a 7? That's the most likely outcome. And I counter that with, yes, it's the most likely outcome, but you're still 5 times more likely to do something else. Right? It's the mode. 6/36 is the mode. But it's still less likely than not rolling a 7, which happens 5/6 of the time. Does that make sense? Now, craps doesn't work just that way. If you roll an 11, you also win on the first roll. And that's not the only way to win. The other ways to win are rolling a 4, 5, 6, 8, 9, or 10 twice before rolling a 7. And when you add up all the ways to win in craps, it ends up being, you've got about a 49.2% chance of winning.
If you play it right.
How do you play it right? It's random chance. You're rolling the dice. It's total randomness. 49.2% of the time you're going to win. That's just a smidge below 50%. And that smidge is all it takes for Vegas to keep its lights on all night. That's all it takes.
Or roulette.
Or say that again, Rachel.
Or playing roulette.
Oh, wait a minute. Roulette, I've calculated that one too. Which one's better, roulette or craps? One's slightly, is craps better, but slightly, by like a 1/10 or 2 of a percent. We should, we'll do a quiz on that one. They all have a house edge, but they're very slight. Roulette versus craps. They're very popular because you lose your money very slowly. Okay, speaking of watching that kind of behavior, let's go back, let's revisit. We now have the distribution, right? Okay, let's see how we're doing up here. Where's my, oh, there it is. Here's our single dice. Look at how little it's dancing now. Isn't that cool? And now we're up to 26,000 rolls. Pretty fun. So that's, what's that, 100 times what you guys did? Almost exactly? Yeah, pretty badass. Nice coincidence. But look, the 16s have stabilized. We're now waiting for the points to stabilize. No, we're not. Because we're done with this one. You get the point, I think. Don't save. What I'd like to do now is I'd like to do a similar simulation on a pair of dice. So in other words, what you guys just did